I am the virtual teacher at Egnatia Career College. Today we'll teach general information for electrical installations, drawings and specifications. This is video number 1. General information for electrical installations. After studying this unit, you should be able to identify the purpose of codes and standards related to electrical systems. Describe the importance of the Canadian Electrical Code. Describe the layout of the CEC. Identify approved equipment. Explain the importance of electrical inspection. Safety. Electrical installations are required to be safe. Because of the ever-present danger of electric shock and/or fire due to the failure of an electrical system, electricians and electrical contractors must use approved materials and methods. Therefore, codes and standards are used to ensure that the exposure of users, installers, and maintenance personnel to the shock and fire hazards associated with electrical systems is minimized. Codes and standards. Codes are standards that deal with life safety issues and are enforceable by law. Residential electrical wiring systems are required to meet building codes and electrical codes. Building codes dictate such things as which rooms and areas, such as stairwells, require luminaires, lighting fixtures, and how they are to be controlled. Electrical codes deal with the actual installation of the luminaires and controls. Municipal, provincial, and federal governments can pass laws regarding the installation of electrical equipment. The Canadian Electrical Code, Part 1 CEC, is the standard that governs electrical work across Canada. The CEC is divided up into evenly numbered sections, each one covering a main division of the work. Each section has a title that describes what will be covered by the section. 10 general sections cover basic installation requirements. The rest are amending or supplementary sections, which change the general requirements of the code for specific types of equipment or installations. Rules in one amending section cannot be applied to another amending section unless they specifically state that they may. The sections are divided into subsections and numbered rules with captions. For example, Section 12 to 500 contains non-metallic sheet cable rules, where 12 identifies the section and 500 is the rule number in the section. 12 to 500 is the first rule of the subsection that deals with the installation of non-metallic sheet cable. The 12 to 500 series of rules, 12 to 500 through 12 to 526, describes how non-metallic sheet cables are to be installed. Tables. At the end of the main body of the CEC are a number of tables, preceded by a list of all of the tables. At the top of each table is a list of rules that refer you to the table, which can be helpful in looking up rules. The tables cover such things as the ampacity of wires, number of conductors in raceways, number of conductors in boxes, and depth of cover over conductors installed underground. Diagrams. After the tables are a number of diagrams preceded by a list of all of the diagrams. Some of the diagrams included show pin configurations for both locking and non-locking receptacles. Some code terminology. Acceptable. Acceptable to the authority having jurisdiction. May. Permitted or allowable. Notwithstanding. In spite of. Practicable. Feasible or possible. Shall. Indicates a mandatory requirement. Shall be. Compulsory, mandatory, a requirement. Shall have. The same as shall be. Shall not. Not permitted, not allowed, must not be. Shall be permitted. Is acceptable, is allowed, is permitted. Other terminology in the form of definitions can be found at the beginning of the CEC in the definitions of Section 0, and at the beginning of some of the sections where terminology specific to the topic covered in that section is given. This textbook is designed to be used in conjunction with the CEC. Throughout the text, reference will be made to the rules, tables, and appendixes found in the 24th, 2018, edition of the CEC. To distinguish these from the tables and appendixes in this text, all references to them are in italics. Standards. Standards describe minimum performance levels for equipment and systems. The Canadian Electrical Code. Part 2, found in Appendix A, consists of safety standards for electrical equipment and is a mandatory part of the CEC. Another standard used in the electrical field is TIA 570A, which is used when installing communication cabling. Personal safety. When it comes to personal safety, you have to make it your responsibility. When you ask most people if they work safely, they answer that they do. The question is, do you know enough about safe working practices to work safely? See if you can answer the 5 questions below. If you can't, you require additional safety training. 1. What are the proper procedures for locking out and tagging electrical equipment? 2. When is a worker required to wear a safety belt or safety harness on a construction site? 3. What are 5 pieces of personal protective equipment? 4. What are the classes of products identified by WHMIS symbols? 5. What precautions should be taken when using ladders for electrical installations? Testing and accreditation. All electrical equipment sold or installed in Canada is required to be approved for its intended use. Approved equipment has met specified safety standards set by federal and provincial governments. Currently, several companies are accredited to approve electrical equipment. Equipment that has been approved by an approval agency will have an identifying label such as CSA or ULC. If you are unsure about an approval label other than CSA or ULC, look for C at the 7 o'clock position on the label. For equipment that has not been approved, arrangements may be made for field approval by contacting the inspection authority in your province. Standards Council of Canada. The Standards Council of Canada, SCC, is a federal crown corporation whose mandate is to promote efficient and effective voluntary standardization as a means of advancing the national economy and benefiting the health, safety, and well-being of the public. SCC fulfills its mandate by accrediting organizations engaged in standards development, certification and testing, by approving National Standards of Canada, NSC, by coordinating participation in international forums such as the International Organization for Standardization, ISO, and the International Electrotechnical Commission, IEC, and by developing standardization solutions for government and industry. For more information, visit https://www.scc.ca. CSA Group. CSA Group is a not-for-profit, member-based organization formed in 1919 to develop standards that address the needs of a broad range of organizations and disciplines. These standards can be used for product testing and certification requirements and are often adopted by provincial and federal government authorities to form the basis for legislation and/or compliance requirements. Thousands of manufacturers work directly with CSA Group to have their products tested and certified, and the CSA mark, shown here, appears on billions of products around the world. The Canadian Electrical Code is one of the many codes and standards that are developed by CSA Group. The Canadian Electrical Code has been adopted by provincial authorities to become law in the various provinces. For more information, visit www.csagroup.org. Underwriters Laboratories of Canada, ULC. Underwriters Laboratories of Canada, ULC, is an independent product safety testing, certification, and inspection organization. ULC also publishes standards, specifications, and classifications for products having a bearing on fire, accident, or property hazards. Electrical inspection. Most electrical safety regulations require that a permit be obtained for the inspection of all work related to the installation, alteration, or repair of electrical equipment. It is the responsibility of the electrical contractor or person doing the work to obtain the permit. When the installation has passed inspection, the inspection authority will issue a connection permit, also called authorization for connection or current permit, to the supply authority. The supply authority will then make connection to the installation. Since local codes vary, the electrician should also check with the local inspection authority. Units of measure. Two common systems of measurement are used in Canada. The International System of Units, abbreviated SI from its French name, Système International des Unités, or metric, and the American Standard Unit, ASU, which uses inches and pounds. Although SI is the official system of measurement in Canada, the ASU system is widely used. Length. The basic SI unit of measure for length is the meter. The SI system has a base of 10, the next larger unit is 10 times the size of the smaller unit, and uses prefixes to identify the different units of length. Construction drawings normally give SI dimensions in millimeters or meters to prevent confusion. The ASU commonly uses inches, feet, yards, rods, and miles to measure length. Construction drawings may use feet, inches, and fractions of an inch as units of measure. A standard steel tape measure that uses ASU units is divided into feet, inches, and fractions of an inch. The first 12 inches of the tape normally has divisions of 1/32 of an inch. The remainder of the tape is divided into 16 ths of an inch. This figure shows how to read a tape measure using ASU units. An architect's scale is used for working with construction drawings that use ASU units. Scales are covered in Unit 2. This table gives useful conversions from ASU to metric units. You can see length, area, volume, liquid volume. Common conversions of trade sizes. Raceways such as rigid conduit and electrical metallic tubing, EMT, are designated by trade sizes because the actual inside diameter of a conduit or tubing is not its stated size. For example, half an inch. Trade size: rigid steel conduit has an inside diameter of 0.632 inches. Half an inch. EMT has an internal diameter of 0.606 inches. And half an inch. ENT, non-metallic tubing, has an internal diameter of 0.574 inches. All are considered to be half an inch, or 16 millimeters, trade size. The 2018 CEC designates raceways in metric units only. The actual size of the raceway has not changed. Only the fact that metric units of measure are used to designate the trade size of the raceway. This table on page 46 of the CEC lists the equivalent metric and American designator units. Outlet boxes are still referenced in inches. The volume of the boxes is given in both cubic inches or cubic centimeters. American wire gauge, AWG, sizes are still used in the 2018 CEC. Metric wire sizes are not identical to AWG sizes. Standard metric sizes generally fall between American wire gauge sizes. This table gives standard AWG sizes and their circular mill area and metric wire sizes and their equivalent circular mill sizes. Drawings and specifications. After studying this unit, you should be able to identify the various types of technical drawings. Identify the line types used on construction drawings. Visualize building views. Read common scales. Explain how electrical wiring information is conveyed to the electrician at the construction or installation site. Demonstrate how the specifications are used in estimating cost and in making electrical installations. Identify and explain the application of the various common line types used on drawings. Explain why symbols and notations are used on electrical drawings. Identify symbols used on architectural, mechanical, and electrical drawings. Technical drawings. Several types of drawings are used in the technical trades. This book uses three primary types of drawings: architectural drawings, schematic drawings, and wiring or layout diagrams. See an example of a schematic drawing and of a wiring diagram in this figure. Architectural drawings show the floor plans of a building and the relative positions and distances between elements within the building. Schematic drawings show all of the significant components of a system and their relationships to each other, but use simplified, standard icons to represent devices. Wiring diagrams are like schematic diagrams. But the pictures used may look like the devices that they are meant to represent, and the layout of the pictures may resemble the actual layout of each device relative to each other device. Technical drawings are used to show the size and shape of an object. The basic elements of a technical drawing are lines, symbols, dimensions, and notations. Lines. The lines that make up working drawings are sometimes referred to as the alphabet of lines, since each one is unique and conveys a special meaning. This figure shows types of lines commonly found on construction drawings. Visible lines. Visible lines are continuous lines that show the visible edges of an object. An example of a visible line would be the outside edge of the foundation wall shown on sheet 3 of the drawings provided with this book. Hidden lines. Hidden lines are short dashed lines. They show the edges of an object that are hidden from view by surfaces that are closer to the viewer. Hidden lines are used to show the location and position of the basement windows on sheet 1 of the drawing set. Center lines. Center lines show the center of an arc or circle. They consist of alternating long and short dashes. The exact center of a circle is normally indicated by the crossing of two short dashes. Section lines. A sectional view, also called a section or cross-section, is a view of a building in which we imagine a portion of the building has been sliced off to reveal the internal construction details. Section lines show the solid parts, example, walls, floors, of the portion of the building shown in the sectional view. Section lines are also called cross-hatching. Different types of cross-hatching represent different types of materials used in the building. In section AA on sheet 4 of the drawings, different types of cross-hatching indicate concrete used for the basement floor, cement blocks used for the basement walls, and bricks used on the outside walls above grade. Cutting plane lines. Cutting plane lines consist of a long dash followed by two short dashes. They indicate where a building is being sectioned. The basement floor plan, sheet 3 of the drawings, uses a cutting plane line to show where the building is being sectioned. The arrows at each end of a cutting plane line indicate the direction you are looking when you are viewing the section. Refer to cross-section AA on sheet 4. Phantom lines. Phantom lines are short dashed lines, about 1.5 times as long as the dashes for hidden lines, that show an alternative position. This figure shows a double-action door where actual positions are depicted with solid lines and alternate positions are dotted lines. Closed switch positions are shown by solid line, while alternate positions are shown with a phantom line. Break lines. Break lines are used where only a part of the drawing needs to be shown. For example, a break line might be used in a connection diagram where it is necessary to show the termination of both ends of a cable but not the cable in between. Contour lines. Contour lines are used on plot plans to show changes in elevation. Dashed contour lines indicate existing grades and solid contour lines show finished grades. Line weight refers to the thickness of a line used on a drawing. Object lines have a heavier line weight, are thicker than other lines, such as hidden lines or dimension lines. Items of other trades that appear on electrical drawings normally have a lighter weight, are thinner than the electrical items. Visualizing a building. Pictorial drawings are three-dimensional drawings that show two or more surfaces of an object in one view. Three types of pictorial drawings are shown in this figure. Figure shows a pictorial drawing of the wiring of a house. Unfortunately, pictorial drawings distort shapes such as angles, arcs, and circles so that it is difficult to show the actual dimensions. Since it is important that construction drawings show the exact size and shape of an object, most construction drawings are two-dimensional drawings. Construction drawings are made using orthographic projection, which shows the true size and shape of an object through a number of views. Each view shows two dimensions. To visualize an object, such as a house, two or more views will often be required. This figure shows an example of orthographic projection. Construction drawings use the terms plan for a top view and elevation for a side view. Plan views. A plan view shows how a building will look when viewed from directly above it. Plan views are used to show lengths and widths. Floor plans and site plans are examples of plan views. This figure shows the first floor plan of the house used as an example in this book. Elevations. An elevation is a side view of the building. Elevations are used to show heights and widths. Elevations are commonly used to show outside walls, interior walls, and the placement of such things as cupboards and equipment. This figure shows the front, south, elevation of the house. Sections. A sectional view of the building, after a portion of the building has been removed, is used to show the interior construction details of the building. This figure shows a portion of section AA on sheet 4. Symbols and notations. Graphical symbols are used on construction drawings to represent equipment and components. Symbols are used to show the size, location, and ratings of equipment. The Standards Council of Canada, SCC, approves national standards for symbols used on construction drawings and accredits organizations such as the CSA Group that are engaged in standards development. CSA Standard Z99.3-1979, 1989, includes symbols for electrical drawings. They relate closely to the symbols published by the Institute of Electrical and Electronics Engineers and the American National Standards Institute, which publish similar standards for the United States. This figure is a portion of a floor plan showing the symbols for 2 3-way switches controlling an overhead light, and 3 duplex receptacles are also shown. Symbols commonly used on construction drawings are shown in this figure A through E. Some other symbols commonly used on construction drawings are shown in this other figure. When symbols are used to indicate future equipment, they are shown with dashed lines, and will have a note to indicate such use. The orientation of a symbol on a drawing does not alter the meaning of the symbol. Lighting fixtures are generally drawn in a manner that will indicate the size, shape, and orientation of the fixture. Symbols found on electrical plans indicate only the approximate location of electrical equipment. When exact locations are required, check the drawings for dimensions and confirm all measurements with the owner or owner's representative. A notation will generally be found on the plans. Blueprints. Next to a specific symbol calling attention to a variation. Type, size, quantity, or other necessary information. In reality, a symbol might be considered to be a notation because, according to the dictionary, symbols represent words, phrases, numbers, and quantities. Another method of using notations to avoid cluttering up a blueprint is to provide a system of symbols that refer to a specific table. For example, the written sentences on plans could be included in a table referred to by a notation. The special symbols that refer to the table would have been shown on the actual plan. If the word typical appears as a notation, it means that construction details are uniform throughout the building. An example would be typical 2-bedroom suite. This indicates that all the 2-bedroom suites are identical. Dimensions. Dimensions are used to show the size of an object. Metric dimensions are normally expressed in millimeters or meters. When the American system of units is used on building drawings such as floor plans, measurements are expressed in feet, inches, and fractions of an inch. This is referred to as architectural practice. There are 12 inches in 1 foot. Building dimensions are normally shown on the architectural drawings, from which all measurements should be taken. Be sure to confirm dimensions with the owner or architect when exact positioning of equipment is required. Scale. A drawing of an object that is the same size as the object is said to be drawn full scale, or at a scale of 1:1. Construction drawings reduce the size of a building down to fit on a piece of paper by drawing everything proportionally smaller than it actually is. This is called reduced scale. A drawing that uses a scale of 1 to 50 indicates that the building is 50 times larger than the drawing. Enlarged scale would produce a drawing larger than the actual object. Printed circuit boards are drawn using enlarged scale since many of the components used in the manufacture of printed circuit boards are very small. An example of enlarged scale is 2:1, which indicates the drawing is twice as large as the component. Types of scales. Measuring instruments. 3 types of scales are commonly used on construction drawings. When the drawing is in feet and inches, an architectural scale is used. For metric drawings, a metric scale is used. For working with civil drawings, example, roads, dams, bridges, an engineering scale is used. This table lists common construction drawing scales. This figure gives examples of reading scales, like metric scale 1 to 100, or metric scale 1 to 50, and so on. The working drawings. The architect or engineer uses a set of working drawings or plans to make the necessary instructions available to the skilled trades that are to build the structure. The plans show sizes, quantities, and locations of the materials required, and the construction features of the structural members. Each skilled construction trade, masons, carpenters, electricians, and others must study and interpret these details of construction before the actual work is started. The electrician must be able to convert the two-dimensional plans into an actual electrical installation, visualize the many views of the plans and coordinate them into a three-dimensional picture, as shown in this figure. The ability to visualize an accurate three-dimensional picture requires a thorough knowledge of blueprint reading. Since all of the skilled trades use a common set of plans, the electrician must be able to interpret the lines and symbols that refer to the electrical installation, and also to interpret those used by the other construction trades. The electrician must know the structural makeup of the building and the construction materials to be used. The drawing set. A set of drawings is made up of several numbered sheets. If there are many sheets in a set, it will be broken down into subsets of architectural, electrical, mechanical, etc. The electrical drawings will be numbered E1, E2, E3, etc. A typical set of construction drawings includes a site plan, floor plans, elevations, details and sections, symbols legend, schedules, diagrams, and shop drawings. Site, plot, plan. The site plan shows the dimensions of the lot, a north-pointing arrow, the location of utilities and their connection points, any outdoor lighting, easements, rights for use of some aspect of the property by someone other than the owner. Example, use of a road that crosses the owner's property. Contour lines to show changes in elevation. Accessory buildings, example, detached garages, storage sheds. Trees to be saved. Floor plans. Depending on the complexity of the building, a set of drawings for a single-family dwelling may have only a single floor plan for each story of the building. As the complexity of the building increases, there will be a number of floor plans for each story, one for each trade. A logical breakdown would be architectural, electrical, mechanical, plumbing, HVAC, heating, ventilating, and air conditioning, structural. On very complex installations, each electrical system such as power, lighting, voice and data, fire alarm, and security access control may have its own plan for each story. Use architectural floor plans to find room measurements, wall thickness, the sizes of doors and windows, and the swing of doors. The floor plans of other trades will show the locations of the equipment associated with that trade. Elevations. Elevations show the vertical faces of buildings, structures, and equipment. Elevations are used to show both interior and exterior vertical faces. Sheet 7 of the drawings that accompany this textbook shows elevations of the kitchen cupboards. On sheet 1, you will find the elevations: south, north, east, and west of the building. Details and sections. Details are large-scale drawings that are used when floor plans and elevations cannot provide sufficient detail. Sheet 8 provides details of the requirements for the installation of a swimming pool. Sheet 7 shows details of the bathroom vanities as well as of the kitchen cabinets. Sections show internal details of construction. See Section AA on Sheet 4. Legend of symbols. Schedules are lists of equipment. The door schedule on Sheet 7 of the plans describes the size and types of doors required for the house. Electrical schedules are made for such equipment as lighting fixtures, luminaires, panel boards, raceways and cables, motors, and mechanical equipment connections. Diagrams. One-line and riser diagrams are provided to quickly show the flow of power throughout the building. Riser diagrams are used to show vertical details while using a one-line format to show power, telephone, or fire alarm systems. Shop drawings. Shop drawings are used by equipment manufacturers to show details of custom-made equipment for a specific job. Installation diagrams that come with equipment could be considered to be shop drawings. Specifications. Working drawings are usually complex because of the amount of information they must include. To prevent confusing details, it is standard practice to include with each set of plans a set of detailed written specifications prepared by the architect. Specifications are written descriptions of materials and methods of construction. They provide general information for all trades involved in the construction of the building, as well as specialized information for the individual trades. Specifications include information on the sizes, type, and desired quality of the parts to be used in the structure. Typical specifications include a section on general clauses and conditions that is applicable to all trades involved in the construction. This section is followed by detailed requirements for the various trades: excavating, masonry, carpentry, plumbing, heating, electrical, painting, and others. The drawings for the residence used as an example for this textbook are included at the back of the text. The specifications for the electrical work indicated on the plans are given in this book's Appendix A. In the electrical specifications, the list of standard electrical parts and supplies frequently includes manufacturers' names and catalog numbers of the specified items. This ensures that these items will be the correct size, type, and electrical rating, and that the quality will meet a certain standard. To allow for the possibility that the contractor may be unable to obtain the specified item, the words or equivalent are usually added after the manufacturer's name and catalog number. The specifications are also useful to the electrical contractor as all of the items needed for a specific job are grouped together and the type or size of each item is indicated. This information allows the contractor to prepare an accurate cost estimate without having to find all of the data in the plans.